Good day, everyone. I am Jasmine Rabor, and I am assigned to report about the DIA linear programming model, which is a continuation of Ms. Saison's report. So, to determine the weight that each hospital will have in computing the outputs and inputs for the composite hospital, we use the following decision variables. So composite hospital is simply the composition of the four hospitals, the composition of the outputs and inputs. And we have four decision variables or the decision making units. So decision making units represent a group of organizational units that are compared in the process of DIA based on their measurements on a certain set of inputs and outputs. So we have four decision variables. WG, weight applied to inputs and outputs for general hospital. WU, weight applied to inputs and outputs for university hospital. WC, weight applied to inputs and outputs for county hospital. WS, weight applied to inputs and outputs for state hospital. So the DIA approach requires that the sum of these weights equal 1. Thus, the first constraint is WG plus WU plus WC plus WS is equal to 1. Next. Table 5.2 shows the annual services provided by the four hospitals or the outputs of the four hospitals. And there are four given outputs, namely Medicare patient days, non-Medicare patient days, nurses train, and interns train. Medicare patient days 48.14 for general, 34.62 for university, 36.72 for county, 33.16 for state. Non-Medicare patient days 43.10 for general, 27.11 for university, 45.98 for county, 56.46 for state. Nurses train 253 for general, 148 for university, 175 for county, 160 for state. Interns train 41 for general, 27 for university, 23 for county, and 84 for state. So there is a general form of the output constraints, which is output for the composite hospital to be greater than or equal to output for county hospital. So ang composite hospital is a composition of the four hospitals. So kaning left-hand side value dere kay ang mo ni siya ang mga output sa four hospitals. Nya ang right-hand side value kay ang output for county hospital, which is the hospital being evaluated. Next, annual resources consumed by the four hospitals or the inputs of the four hospitals, and there are three given inputs, namely full-time equivalent non-physicians, supply expense, and bed days available. Full-time equivalent non-physicians, 285.20 for general, 162.30 for university, 275.70 for county, 210.40 for state. Supply expense, 123.80 for general, 128.70 for university, 348.50 for county, and 154.10 for state. Bed days available, 106.72 for general, 64.21 for university, 104.10 for county, and 104.04 for state. So the same for the output constraints. There is also a general form for the input constraints, which is input for the composite hospital is to be less than or equal to resources available to composite hospital. So the same, the left-hand side value kay composition ra siya sa mga input sa four hospitals. gipang substitute ra niya sa right hand side value kay ang inputs sa county hospital, the hospital being evaluated, and if makabantay mo kay sa kilid kay naa na ni ang E. Ang kani nga E is the fraction of county hospital's input available to the composite hospital. So ang kaning E kay fraction daw ni siya sa county's hospital's input or ang part sa county hospital's input available to the composite hospital. And it is also referred to as the efficiency index because of the effect that E has in determining the resources available to the composite hospital. So if E is equal to 1 daw, the composite hospital requires as much input as county hospital does. However, if E is less than 1, the composite hospital requires less input to obtain the output achieved by county hospital. Next, the logic of a DM model is to determine whether a hypothetical composite facility can achieve the same or more output while requiring less input. If more output with less input can be achieved, the facility being evaluated is judged to be relatively inefficient. So mauni nga naatay general form for the output constraint and for the input constraints. For the output constraints, it should be greater than or equal to the output of the county hospital, which is the hospital being evaluated. And for the input constraints, it should be less than or equal to the available resources. Kay mao man jud na ang goal sa tanang organization to maximize its output and minimize its input. So the objective function in a DEA model is always minimize E. So mao ni ang E katong ganina referred to as the efficiency index nga ang if E daw is equal to 1, ang composite hospital must put the same input as county hospital does. However, if ang E is ma-minimize or less than 1, then ang composite hospital requires less input to obtain the same output of county hospital, which is the goal. So the DIA linear programming model for the efficiency evaluation of county hospital has 5 decision variables and 8 constraints. So ang 5 decision variables ani nila kay mao ni ang katong E, katong efficiency index ug ang katong weight applied to inputs and outputs for the general, university, county, and state hospital. And there are 8 constraints in which 4 are output constraints and 3 are input constraints. So the 4 output constraints, Medicare patient days, non-Medicare patient days, nurses train, and interns train. While the 3 input constraints are the FTE and physicians, supply expense, and bed days available. So figure 5.3 shows the solution for the county hospital data envelopment analysis problem. So the value of the objective function shows that the efficiency score for county hospital is 0.905. This score tells us that the composite hospital can obtain at least the level of each output that county hospital obtains by having no more than 90.5% of the input resources required by county hospital. Thus, the composite hospital is more efficient and the data analysis identified county hospital as being relatively inefficient. So, naatay lima ka variable. Ang katong E, the efficiency index is the same value for the optimal objective value. Unya, ang four variables, the general, university, county, and hospital, kay it should be equal to 1. The sum of its value kay mao na siya ang first constraint. So, ang county hospital, iyang value na kay 0 kay it is already judged as relatively inefficient. Unya, ang nainabilin nga 3 for the value sa general university og state, if i-add ni nato silang tulo kay mo equal ni siya sa 1. And And for the county hospital, kay naa siya reduced cost. So, ang kaning reduced cost is the amount by which an objective function coefficient would have to improve. And for a minimization problem like this one, reduced cost means to decrease. So, county hospital should decrease up to 0.09476 for it to be efficient. So for the eighth constraint in the slack and surplus column, constraint 4 means that the composite hospital provides 1.6 more nurses trained, and for the constraint 5, it means that the composite hospital provides 37 more interns. And the slack values for constraints 6 and 7 shows that less than 90.5% of the FTE non-physician and the supplies expense resources used at county hospital are used by composite hospital. And for the eighth constraint, which has a value of 0, which has a slack of 0, shows that the composite hospital uses approximately 90.5% of the bed days used by county hospital. And it is also shown in here the dual value of the eight constraints. And the objective coefficient for the E, the efficiency index, has a 1 value. And for the eight constraints, it also has its right hand side value, which is computed by multiplying the output value or input value of the county hospital to its value, which is 0. So ang right hand side value is just the same, and it is also shown the allowable increase and the allowable decrease of the constraint. So the allowable increase is the amount by which you can increase the coefficient of the objective function without causing the optimal basis to change. And the same for the allowable decrease is the amount by which you can decrease the coefficient of the objective function without causing the optimal basis to change. Next is the summary of the DIA approach. So, DIA, data envelopment analysis, it's all about evaluating efficiency, maximizing output with keeping input constant, minimizing input with keeping output constant, or both at the same time. So, we have 6 steps in formulating the DIA linear programming model. Step 1, define decision variables or weights, one for each operating unit that can be used to determine the inputs and outputs for the composite operating unit. So, mao ni ganina nga natay 4 decision variables katong WG, WU, WC, and WS. So step 2, write a constraint that requires the weights to sum to 1. So katuning WG plus WU plus WC plus WS is equal to 1. And step 3, for each output measure, write a constraint that requires the output for the composite operating unit to be greater than or equal to the corresponding output for the chained operating unit. So, mao ni ganina nga natay general form for the output constraints that output for the composite hospital is to be greater than or equal to the output of the county's hospital output. Step 4, define a decision variable E, which determines the fraction of the joint operating unit's input available to the composite operating unit. So, mao ni katong E, the efficiency index. Step 5, for each input measure, write a constraint that requires the input for the composite operating unit to be less than or equal to the resources available to the composite operating unit. So, mo ni ganina ang general form for the input constraint. That input for the composite operating unit should be less than or equal to the resources available to the composite operating unit. And lastly is write the objective function as minimize E. That is